GeoBIM connects the built environment with its geographic context.
This is where BIM meets GIS.
Okay, let's dive in. If you work in city building, infrastructure design, or managing big assets, you definitely know the feeling, that frustration of data silos.
Oh, yeah. It's like having two critical, massive sets of information that just, well, refuse to play nicely together.
Exactly. On one hand, you've got your geospatial data, your GIS, that's the where, the context, topography, population, utilities, soil, all that location stuff.
And then the other piece is your BIM model, building information modeling.
Right.
This is the super detailed 3D design model. You know, the walls, pipes, materials, down to the nuts and bolts.
Right, and when the AEC pros, architecture, engineering, construction, are stuck working in their own bubbles, they end up having to manually transfer data or worse, rebuild it. It just creates friction, big delays.
It really hinders making those truly collaborative, real-world design decisions. And historically, that manual correlation, that's been the biggest headache.
We're talking about crucial phases, design, review, even managing the asset later on, all happening on platforms that just didn't share that vital context naturally. So the tech strategy that's finally tackling this head-on is what we're getting into today, GeoBIM. It's this deliberate, seamless integration of the geospatial stuff and the detailed building design data.
And look, this isn't just some theoretical idea anymore. This is being driven by the two absolute giants in these fields. You've got Esri, the GIS leader.
And Autodesk, who own all those key BIM and design tools like Revit and Civil 3D.
Exactly.
So our mission today, it's really to show you how this interoperability bridge actually works, why it's such a game changer for these huge projects. And maybe most excitingly, where the really interesting applications are popping up, things like calculating carbon footprints precisely, or even feeding data into AI.
There's a lot to unpack there.
Okay, so let's start with the why. The strategy behind building this bridge. I mean, why did these two major players, often competitors, decide they absolutely had to link up?
Yeah, that's a fair question. You know, when tech giants collaborate, sometimes the worry is you just get locked into two complex systems.
Right. Is it just a convenient deal, or is it genuinely about making things work better for the user? What did the source material suggest?
Well, the material tackles that directly. It seems the push really came from the industry itself, dealing with those fragmented workflows we mentioned. People like Martin Day discussing it with Esri's director Goldman pointed this out.
Okay.
The core goal of this Esri-Autodesk partnership, and this seems key, is not about merging the companies. It's not about forcing everyone onto a single mega platform.
That would be chaos, wouldn't it, given all the legacy data?
Absolutely disruptive.
Yeah.
Probably impossible. So no merger.
So if they're not merging, the focus is purely on making that data bridge work.
Precisely. It's all about building really solid connectors, making their existing platforms and all that data fully interoperable. It enhances the workflows people already use day to day.
So respecting the tools people are already comfortable with.
Yes. The industry basically demanded it, you know. The design model, the BIM, it has to understand the coordinate system, the real-world context that the GIS provides.
And that really gets to the core value proposition, doesn't it? GeoBIM providing that common data standard for these big, complex projects. But why is that standard so hard to achieve in AEC anyway?
Well, think about the scales. GIS data is often macro citywide, kilometers, maybe meters. BIM data is micro down to millimeter precision for like a door hinge or a pipe fitting.
Ah, right. Different universes, almost.
Trying to correctly place a super detailed BIM model with all its material properties inside a large, geographically accurate GIS map. Historically, that was a manual, tedious job. Very easy to make mistakes. GeoBIM is about automating that fusion.
Got it. So the payoff, the big benefit, is that customers can finally visualize GIS context alongside BIM content and object properties. That phrase really sums it up.
It does. You see the building and the world it lives in at the same time, seamlessly.
And crucially, this works even if the actual design files are sitting in the Autodesk Construction Cloud, the ADC.
Yes, exactly. The ACC acts as that common data environment, kind of the central hub where all the different collaborators and data streams come together.
So it pulls everything together.
Right. And this integration, it fundamentally shifts how knowledge gets created. It moves it out of those isolated desktop silos into one continuous digital workflow, spanning the whole project lifecycle, really from the first concept sketches, through design review, handover, and even managing the asset long-term.
Moving knowledge from separate desks into one seamless workflow.
Yeah, that sounds like a real transformation. Okay, so if the why is bridging that gap, the next big question is how. How does the tech actually make, say, a detailed Revit model and an ArcGIS map share information without losing that critical object intelligence?
It comes down to some deep platform interoperability that's now built into both software suites. So from Esri's side, their ArcGIS platform now has direct links into core Autodesk's tools, think Revit, Civil 3D. This makes sure the BIM model is spatially referenced correctly right from the beginning. It optimizes performance, streamlines data flow, which is absolutely critical for those really spread out projects like roads or rail lines or utility networks. Makes sense. And does the connection work the other way too, making it easy for Autodesk users to grab that spatial context from Esri?
It does, yeah. Autodesk built a direct web-based link right into their platform that gives users instant access to the ArcGIS Living Atlas.
Living Atlas?
Yeah.
Tell us more about that. Is it just like a fancy map?
It's much more than just a map, actually. Think of it as a huge, constantly updated library of high-quality geospatial data.
Okay, so what kind of info is in there that, say, an engineer using Civil 3D would find useful right away?
Oh, all sorts. High-res global topography, detailed property boundaries, existing utility lines, complex soil reports, population density layers. Basically, all the critical stuff you need to check if a site is even feasible before you place the first virtual brick in your design.
So it stops designers from essentially working blind, spatially speaking.
Exactly. Prevents designing in a vacuum.
Now, what seems really powerful here, and where GeoBIM really steps up, is that it's not just about swapping geometry, like shapes on a map. It's transferring the geometry plus the object properties and the crucial metadata about coordinate systems.
Yes, this is the absolute technical core. The geometry is just what it looks like, right? The object properties, that's the intelligence.
What specifically?
We're talking about data like what material something is made of, its cost code, fire rating, maybe specific maintenance schedules, insulation values, stuff like that. If you want to calculate the lifetime cost of a building, you need both the geometry, the size, the area, and the properties like material cost and how long it lasts. GeoBIM connects those instantly.
And it's that intelligence that unlocks the really advanced analytics, moving way beyond just looking at a combined picture. We saw some visuals showing GeoBIM in action, and you can see detailed filtering of building elements. But the real power seems to be in those precise calculations you can do because you've linked the design object properties to the real-world context.
And that brings us right to that really striking example from the source material.
Yeah.
Tracking environmental impact.
Right.
Because the system knows the volume and the material type of every single thing in the BIM model, and it knows exactly where it sits from the GIS side. It can calculate the carbon footprint with real precision.
And they gave a specific number, which really drives it home. A calculation showing 42,350 kilograms per square meter of CO2 equivalent.
Yeah, and just to give that some context for you listening, that figure likely refers to the carbon emissions linked to maybe the total floor area or perhaps the facade area of a section of the project.
Okay.
The key point is doing that calculation before. That would have meant getting two different specialists, a BIM person and a GIS person, to manually mash that data together. Now, because GeoBIM fuses the object properties and the location data automatically, you get that specific auditable number almost instantly.
That really shifts planning, doesn't it? It's not just about looks or engineering specs anymore. It's about mandatory, measurable environmental tracking.
Precisely. It becomes part of the core workflow.
So, moving from the mechanics to the real world, where are we seeing this GeoBIM integration actually making a difference on large-scale projects right now?
Well, urban planning is probably the most obvious and immediate success story. GeoBIM is fundamentally changing how planning happens, moving it away from static, often 2D historical snapshots towards really dynamic, detailed spatial analysis.
Yeah, it makes it more accessible too, right?
Hugely. It sort of democratizes the data access because people can run pretty advanced analyses without needing, years of specialist GIS training.
Can you give us a solid example? Like, how would a planner use this?
Okay, imagine you're trying to improve services in London. A planner could use the GeoBIM setup to map out all the London tube stops, that's the infrastructure data, probably from BIM or CAD initially.
Right.
Then they overlay that with demographic and social data from the GIS side, maybe layers showing areas of poverty, health, vulnerability, metrics where the green spaces are located. What you get is this rich, dynamic map showing spatial accessibility. It helps understand exactly how infrastructure impacts different communities, informing decisions about social policy, where to invest. It connects the physical city to the social fabric.
That's powerful stuff. And This capability, it didn't just spring up overnight, did it? We saw mentions of earlier European research projects.
No, absolutely not. We're definitely building on solid foundations here. Those projects mentioned LE1FT, Giraffe, GeoVigo, EED. They were really important. They were the academic and industry trials that basically proved the concept of GeoBIM could work.
So they laid the groundwork.
Exactly. The big difference now is that this strategic link up between Esri and Autodesk has taken that proven concept out of the lab, out of the pilot stage, and turned it into a high-performance, commercially available toolset that pretty much any AEC professional worldwide can access. The field has definitely matured.
Okay, and this is where you said it gets really interesting for the future. The next big step is taking all this clean, integrated GeoBIM data and feeding it into machine learning and AI models.
Yes, this is where the potential explodes. AI absolutely loves highly structured, spatially referenced data, and GeoBIM is perfectly set up to provide the kind of detailed 3D vector data that AI models thrive on. This is how we shift from just describing what is currently there to actually predicting what could happen.
Okay, prediction. So once AI gets its hands on this rich, integrated data, what are the main things it can do? What are the key use cases?
The source material highlights about 4 key areas. First off, automation. Think about automatically segmenting roads or buildings from satellite or drone imagery.
Saving a lot of manual work.
A ton. Second, speeding up object property capture. Imagine using reality capture like laser scanning an existing building in an AI model trained on GeoBIM data, automatically identifies and tags all the assets. You can recognize materials, dimensions, maybe even manufacturers.
Wow, okay, that would massively cut down on manual surveying time and effort.
Absolutely. Then the third area is that predictive modeling we touched on. Using the data to predict serious risks, maybe modeling climate change impacts on infrastructure, understanding potential points of failure in a utility network before they happen, or even anticipating structural weaknesses.
Proactive maintenance and risk management.
Exactly. And the fourth application, and this might be the most transformative in terms of access, is enabling natural language queries for people who aren't specialists.
Meaning you can just ask the data questions.
Pretty much. It essentially democratizes access to all this complex GeoBIM data. So instead of needing a highly trained GIS analyst or BIM manager to run some complex query,
Right.
a non-specialist, maybe a city council member, an operations manager on site, perhaps even just an interested citizen, could simply ask a question about the project or the asset in plain English.
And get an intelligent answer back.
And get an intelligent, spatially aware answer that's pulled directly from that underlying integrated model. That's a huge shift in accessibility.
Okay, so let's pull this all together. The key shift GeoBIM represents. It seems we're moving away from these isolated design files and separate maps toward the truly dynamic, spatially aware environment. One where the detailed object intelligence and the real-world context are completely linked up.
That's a great way to put it. It really underpins genuine digital transformation. And not just for the designers up front, but for everyone involved across the entire life cycle of that building or piece of infrastructure.
Right.
Being able to properly link that geospatial context, the wherewith, the really granular object properties from the design model, the what, that's absolutely essential if you want to make better, faster, smarter decisions throughout the asset's entire life.
It sounds like the foundation needed for the AEC industry to move beyond just documenting things towards actually predicting and optimizing them.
Exactly. It's the platform for that evolution from documentation to prediction. That synthesis is achieved through making things interoperable. Now, here's something to think about. Building on that idea of AI enabling natural language queries. What actually happens when this incredibly complex, high-quality, 3D GIS-rich data information that used to be locked away, only really usable by specialists with years of training?
Yeah.
What happens when anyone can access and analyze that data just by asking a question in plain language? If that barrier to entry disappears, what new kinds of jobs might emerge? What new collaborations could spark between, say, city leaders, community groups, engineers, planners,
Yeah.
all looking at the same deep data?
Yeah.
How does that fundamentally change how we develop our cities and our environment?
That's definitely something to mull over next time you're looking at a city plan or a construction project. A potential future unlocked by data.